y'all doing? My name is Ben Toman, and I am a member of the Baton Rouge Astronomical Society. We've been doing some live streams of the moon through our telescopes this past week, and we had a couple of requests to maybe do a little informational video on the moon that some of the teachers could use to send out to all of the kids that are going through schooling at home right now. So let's go take a look. We have this excellent moon banner here that's going to help us kind of learn a little bit about the moon before we go out later and take a look at it through this telescope. First of all, the moon is about 1/4 the size of our Earth. It orbits at about 240,000 miles away on average. It takes about 27.3 days, roughly 1 month, to complete one orbit around the Earth. Size-wise, we said that it was 1/4 the size of the Earth. To put that into perspective, it is about 2,159 miles across, and our own country, the United States, is 2,800 miles across. So you can start to get an idea of how much smaller it is than the Earth. Because of that, it also has about 1/5 the gravity that the Earth has. And that's why when you see videos of the astronauts that actually walked on the moon, they seem to be kind of lightly bouncing around a little bit, and that's because of the lower gravity on the moon. Let's talk about why the moon kind of looks the way it does to us when we look up at it. When we do look up at the moon, the first thing we're going to notice are these large, dark colored areas. Now, they call those the lunar maria. Maria was Latin for seas, because way back in the day, when they used to look up at the moon, they thought that these dark areas were actually liquid seas or oceans. We know that's not the case now, but these areas were formed by pools of molten lava that ended up cooling. The other thing that we're going to see all over the surface of the moon are these little pock marks, these holes. These holes are called craters. Craters were formed when asteroids or meteors or comets crashed into the surface of the moon. Some of the craters, and a couple of the big ones we're going to look at tonight, this one down here is called Tycho Crater, and this one up here, Copernicus Crater, have these really cool spiky starlight patterns that surround them. We call those spikes rays, and they are just, it's just ejected material. When that asteroid or meteor smashed into the moon, lighter colored material from underneath came flying up and out and spread out across the surface of the moon. And so you see that prominently on both of these craters. And we'll see that later on tonight. All right, I wanted to do a quick little demonstration of how some of those craters get to looking the way that they do. This is our little simulated surface of the moon. We've used white flour to simulate the material that's underneath the surface, and we use cocoa powder spread on top to simulate the darker basalt material that's on the surface of the moon. So our little simulated asteroid or comet is going to smash into it, and just like we see on the moon, the lighter material from underneath is going to be thrown up and ejected out. So perfect little crater, and as you can see, just like we see on Tycho and Copernicus, you've got these rays of ejected material that come flying out all around it. Pretty fun. The other thing that we notice when we look at the moon are its phases. The moon goes through several different phases in its roughly 1 month as it orbits the Earth, depending on how the sunlight is reflecting off of it from our point of view. It's going to start out, we're not going to see the moon at all. We're going to call that the new moon phase. It's not reflecting any light at us yet. As it starts to catch some of the rays of the sun, we will get the crescent moon. As each day goes, that crescent is going to become larger and larger until we get to that half moon phase, which we call first quarter moon. You have to think of a pie and cut it into 4 sections. And so that's why we call it first quarter moon, because this is the first quarter that it has taken to get there. After that, it's going to continue to grow. Now we're going to call it a waxing gibbous moon. Waxing, of course, means to get larger, add more to it. On its way up to the full moon. So now we are halfway through the lunar cycle, and we're at full moon. So now the sun is directly overhead from the moon's point of view and illuminating the whole face. After that, it's going to go to a waning gibbous moon. So large, waning of course means to lessen or take away. And then we'll go down to last quarter moon next, which is going to be just like first quarter moon, a half a moon, but now the side that was dark earlier is going to be the lit up half of it. And then down again to another crescent moon and complete the cycle at a new moon. Now we're going to take a look at some video that I shot through my telescope outside the other night. Normally when we look through a telescope, we're going to look right through the eyepiece here and see what we can see. In order to bring you along with me, I have this special little mount that attaches to the eyepiece of the telescope so that I can place my cell phone in that mount, and now the cell phone's camera is going to capture that video. Some of the things that we are going to look at, you're going to hear me rambling on a bit. You're just kind of along for the ride out here on this lunar observing session. But I will point out Tycho Crater. I do point out Copernicus Crater and some of these smaller craters that are up in this area. This cool little mountain range area here we call the Bay of Rainbows. And just so you can see it on this map and maybe make it easier for you to see in the video, right down in this area, this large area, they call it the Sea of Tranquility. This is where Apollo 11 landed, right in this little area here. That was where men first stepped foot on the moon. This area here that I will talk about is the Sea of Serenity, Mare Serenitatis. And it was right around in here that Apollo 17 landed, and right down in this area that Apollo 15 had landed. So just wanted to point those couple of areas out before we take a look at this video. So let's go take a look.
Okay, so here we are looking at the moon. It is April 3rd at about close to 9 o'clock Central Time. I'm here in Louisiana. And this is a live image of the moon. A little bit bright. It's a little bit washed out, but as you can see, because of the phase that the moon is in right now, it's a waxing gibbous moon. And so the moon, or the sun, is hitting the moon at an angle. And because of that, we have that, it looks like the light part of the moon just ends right there at darkness instead of being a full circle or a full globe. And where the light meets the dark, that's what we call the Terminator, because that's where the light ends. And there are a few cool craters and things that we can see. That's the neat thing about looking at the moon when it is in phase, is we are able to see the definition of the craters and some of the depth of some of those craters. Demonstrate that. We'll move around a little bit here and zoom in on some of these craters. Even though they may look like they're kind of small, a lot of those craters that we're seeing are many miles across. When you look up at the moon without looking at a telescope or using binoculars, the the smallest thing that we can make out up there just with the naked eye is still about 60 miles across. So let's see if we can get some of the names of some of these craters real quick. So that really cool crater we're seeing right there, kind of in the center. I'll put it in the center of our field of view here. You can see the rim of that crater lit up all the way around. That is Crescent Crater, and it is 101 kilometers across. So that's a pretty big crater. And you can see right on the edge of that crater, there's another smaller crater. And so we know that that smaller crater is the newer crater because it impacted onto the already existing crater and wrecked its little crater wall. But again, because the sun is hitting the moon at an angle, the height of this crater wall is catching the sunlight still, so it is reflecting that sunlight back, and so all the way around, almost all the way around, we can see it reflecting the sunlight, and it's lit up. But inside that crater, the sun is not high enough to get down into the depth of that crater, so it's still in shadow, except for that little white peak in the center. And that is a rebound peak from when that asteroid or meteor, whatever it was, that crashed into the moon. That's a rebound peak of rock and dirt left over. Imagine if you're looking at a pool of water or a puddle, if you drop a pebble into that pool of water, ripples go out in a circle, but immediately after you drop it in, it plunges in and then pop back up in the center. Some like a peak of water pops up. And the same kind of thing happens when an asteroid or a meteorite crashes into the moon, or even here on Earth. Believe it or not, we have lots of craters like this all over the surface of the Earth as well. We just can't see them, well, too many of them very well, because most of the Earth is covered by water. So a lot of these asteroids or meteors smashed into water and didn't leave a big crater. And the ones that did smash on land, oftentimes, because we have a significant atmosphere on the Earth, then we have erosion and weathering and rain and tectonic plate movement. All that kind of stuff has kind of eroded a lot of those craters over time, or they're covered up by vegetation, trees and plants and whatnot, and we just don't even know they're there. Maybe your teacher can pull up a picture of Meteor crater in Arizona. That is a very large crater here on Earth that you can actually go visit, and you can see that entire crater because it was out in the middle of the desert where that meteor crashed a long time ago. And so we can still see the evidence of that crater, and it looks similar to a lot of these craters we're seeing tonight here. So that was a pretty easily distinguishable crater that's pretty cool. This crater right here, you will have seen earlier. Right in the center there is Tycho Crater, and you can still see those rays, we called them, all that ejected material that came out that makes that giant, almost like a star-like pattern flying across the surface of the moon. And again, we know that that crater is a younger crater than a lot of them around it, just because it's the most prominent one in that field, and the material that it threw out is on top of everything else around it. So it had to have happened after some of those other impacts had happened. And we'll just look down here real quick as well, just because this is a significantly named crater anyway. This is a pretty pretty neat crater itself. This big one that seems to be all by itself out in the lunar landscape there. And that crater is Copernicus Crater, so named after the Copernicus, who was one of the earlier people to put forth the idea that everything didn't revolve around the Earth. Galileo used a lot of Copernicus's work when he started finding out that things were not all orbiting around the Earth, that maybe everything was going around the sun. That's what they thought. They called that the Heliocentric Model. They believed that everything orbited around the sun. Which turned out to be at least closer to correct than what they had believed before, that everything went around the Earth. Of course, everything doesn't go around the sun. The moon actually goes around the Earth. Jupiter, Mars, Saturn, they all have moons that orbit their own host planet. And then our whole solar system, our sun, is actually orbiting around the center of the Milky Way galaxy. And there are, we'll go take a look down here. There are mountain ranges on the moon and valleys. This is kind of a partial, probably partially made by an asteroid impact or something a long time ago. But you see that little arc down there towards, well, now kind of in the center, but towards the bottom of the limb of the moon here. They call that the Bay of Rainbows. And real quick, I don't want to make this too long, but we'll move over to this area here real quick. And now, right here in the center of the field of view, this area that we're looking at right now, in fact, I'll put this whole area in here right now. So the large dark area to the left, they referred to that, it's called the Mare Tranquillitatis, which was Latin for the Sea of Tranquility. Way back in the day when these people were naming features on the moon, they thought that that was probably a liquid sea, and that's why it looked darker than the rest of the area around it. But they are actually like leftover, probably volcanic lava flows and stuff from back when the moon was forming. And then the one to the right of it, that dark portion, is Mare Serenitatis, so the Sea of Serenity. But the one on the left, like we said there, the Sea of Tranquility, and if you look to its upper left, maybe imagine a clock face in about the 11 o'clock area there, is a little kind of a prominent lighter feature that juts into the darker area, and it's just to the right of that Apollo 11 landed. And that was where Neil Armstrong and Buzz Aldrin were the first human beings ever to step foot onto the moon. Let's zoom out one more time. Take a look at the moon. just because it's really neat. We're going to zoom in one last time. Take a look at some of that heavy bombardment cratering that was happening in this area of the moon. There you can just see how there are just hundreds of little craters all over the surface there. And there are still impacts happening all the time on the surface of the moon. Every once in a great while, somebody gets lucky. Somebody will be looking at the moon through a telescope and maybe videoing it like I am right here, and they'll see a quick little flash of light, and later on there ends up being a new crater there. And that's because they just saw a small meteor or a very small asteroid crash into it. It's rare to actually see it happen, but these impacts are happening all the time, just like they still happen here on Earth. When you see a shooting star at night, if it's large enough, that object, it can make it through the atmosphere without burning up and actually crash into the ground someplace. I could look at this all night, but I think we'll leave it at that. And I hope you enjoyed checking out the moon.
All right, well, I hope that you enjoyed watching this video, learning a little bit about the moon, and especially checking out the footage of the moon that we had through that telescope. Once again, I'm with the Baton Rouge Astronomical Society, and we're here in Louisiana. Please visit our website at www.brastro.org. We also have a Facebook page. Go give that a like. Check out some of our live feeds that we do there on the moon and some other stuff. And of course, we are newly on Instagram and Twitter. I would like to also point out that we are a member organization of the Night Sky Network. This is a nationwide organization that is an excellent resource for finding out what kind of astronomical events and things are going to be going on in your own community. So once again, thank you very much, and I hope that you all be well.